Scenario: a 2 kilogram pendulum bob is raised to 1.5 meters above the floor, as shown in the figure. The bob is then released from rest. Question: what type of potential energy does the pendulum have? Answer: the gravitational potential energy, because it is above a certain height. Question: what is the maximum potential energy that the pendulum can have? Let's look at the answer. The gravitational potential energy is defined by mgh, mass, gravity, and height. Plug in the values. The mass is 2, the gravity is 10, and the height is 1.5 meters. You should now get 30 joules. That is how much the gravitational potential energy is at that moment. The next question: the bob now swings and goes down to a new height that is 1 meter above the floor. What is its speed at that moment? That speed that they're looking for is the velocity. So the answer: we are here going to use the conservation of energy, where the change in the height is 0.5. How am I getting that height value of 0.5? I'm getting it from the original, which is 1.5, minus 1.0, which is the final height, which is equal to 0.5. If you did it the other way of final minus initial, you could also do that, but you're going to get a negative 0.5. Okay, the change in that height's potential energy will be the kinetic energy of the bob. Ug is the potential, K is equal to the kinetic. I make the substitution in for the variables. So even if you plug it in, you're going to still just get a negative value. So watch. It is mgh is equal to 1/2 mv squared. You're going to see that the masses here cancel. Then you're going to multiply both sides by 2. Then you're going to take a square root. So v is equal to the square root of 2gh. Notice that if you use this height value here is equal to negative 0.5, it's going to hurt this equation. Okay, because you can't take the square root of a negative number and get real solutions. That's the reason why I did it this way. Okay, so that change in that height is really 0.5. That's how much the height changed. Okay, so ignore the negative. So if you plug in the values, square root 2 times 10 times 0.5, you get the velocity equals to 3.16 meters per second. That negative just indicates that it actually lost potential energy and gained velocity as it went down, which makes sense. So the final velocity is 3.16 meters per second squared, because the height, again, that was changed is 0.5. All right.